Welcome to Unit 3. You have survived 2 whole units in your Math 8 class. Good job. Hope you did well on the Unit 2 test. I hope you took it. If you didn't, make sure you get that done. So our goal today is to determine whether a number is rational or irrational. And of course, we're following the Pennsylvania standards. So a rational number is a number that can be written as a ratio. Okay, ratios are nothing but fractions. You guys know what fractions are, right? It's a fraction, though, that where the numerator, which is our top number, and the denominator, which is our basement number, they're both whole numbers. Now, you probably haven't really given that a whole lot of thought before. But let's talk about what kind of rational numbers, what kind of numbers are rational. Any whole number, okay, could be positive or negative. Fractions, like I said before. Terminating decimals. Oh boy, terminating. What does that mean? A terminating decimal, if you think about the movies, the Terminator, what does he do? He terminates lives. He ends lives. So a terminating decimal means a decimal that has an end, like 0.25. Stops, right? Terminates. So that's what it means when I say a big number like terminating decimal. You know these words. Repeating decimals. That would be a number, and you'll see an example in a minute, where it has a either one digit that it repeats, like 0.33333333, or a couple of numbers like 0.213131313. The 13 repeats. Okay, so those are repeating decimals. They're kind of stuck and they just repeat forever. And another example is square roots of perfect squares, because when you take a perfect square and take the square root of it, what do you get? A whole number, which is the top thing that we are talking about. So here's some examples. There's a whole number, 698, sorry. We've got 5 over 13. That's just a good old fraction. And notice this, 4.7975, and it stopped, okay? It just stops. That's a terminating decimal. It's a little bigger than what we're used to seeing sometimes, but it terminates. It ends, okay? It doesn't go on forever with some random bunch of numbers. And this one repeats. The 4, 5 repeat. That's okay. And hopefully you remember that the square root of 36 is 6. So if you can take the square root and end up with a whole number, then you know you've got a rational number. Rational, to me, is a number that makes sense. I can understand it. I can say $698. It's an amount I can grasp. My brain can grasp it. However, irrational people, my brain just can't make any sense out of them. So when somebody's being irrational, it's like we can't make sense out of it. And so a number that's irrational, it's kind of like a number we can't make sense out of. Because look at that second sentence there. It says an irrational number has endless non-repeating digits to the right of the decimal point. I mean, who can fathom? It's like it goes on forever, to infinity and beyond. Who can grasp that? I just can't make sense out of irrational. All right? It's just something we have to say, all right, it's there. Irrational exists, but I can't understand it. It's okay. All right? It can be written as a decimal, but it would never become a fraction. I know right now that's not making a whole lot of sense. Just consider the fact that irrational numbers are the ones that don't make sense. Here's simplified, okay? Taking a decimal that doesn't end, doesn't terminate, and it doesn't repeat. It just goes on and on and on. You stick it in your calculator and you're like, yeah, it goes on forever. Another way to get those is to try to take the square root of something that's not a perfect square, okay? All right, let's see some examples of that. My pal Pi. I love pi. Okay, I love pi with an E on the end, but I like pi too as a math teacher. I'm supposed to like the pi. Pi itself goes on forever. Scientists and computers have tried to figure out for years years, how far out pi goes, and they can't find an end to it. So pi itself, we don't know the exact amount because it goes on forever. Okay, so pi divided by anything is still going to give us this forever thing. Okay, notice that third 5.76339870111. We think we're going to get a repeat there, but no, it goes into 837, and that's plenty far enough to know that number does not repeat. It's going on forever. So it makes no sense. It doesn't have an end. That's what the dots mean, right? And the square root of a non-perfect square, 51. 49 is a perfect square, and above it is 8 times 8, 64. But 51 isn't. So if we take it a square root of 51 on our calculator, we get this really big, long number that just keeps on going and doesn't ever end. So I want to show you. I know a lot of you think and reason visually. So here's a little chart, and I'm putting it in our cheat sheets, help sheets, whatever, so you can see it. Okay. Rational numbers. This is our all of our rational numbers. And over here is a little box with just our irrational. It's easier to say what's irrational. When you see some funny little symbol, Greek symbols these are, okay, that's what the little e and that, I forget what that one's called, and the pi, square roots, and there should be a decimal in there as an example. But anyway, these are irrational, and it's easier to say what's irrational and then say everything else is rational. Natural numbers, those are the ones you count with, your fingers, your toes. And then whole numbers, whoops, where's my pointer? Include the zeros. Include zero, okay? Whole numbers include zeros, the zero, and then we include integers, okay? Integers are down here. They include all the negative numbers. And then last, we got more, all rational numbers are fractions, and this should show decimals that terminate. And if you put any of these into your calculator, because you guys all know that that line means division, if you put that into your calculator, these numbers end, they terminate, okay? So it's easier actually to say what's not rational, because it's very few things are irrational, very few. So what I want you to do is think about 3/4. You can even put it in your calculator. Test it out. If you put 3 divided by 4 in your calculator, you get a rational number. Okay, try this one on your calculator. The square root of 7, is that rational? Okay, with 0 on the list of rational numbers, you can take a peek at your little chart there. All right, is 8 irrational? I've switched the question on you now. Pay attention. Is that considered irrational? If it's rational, then it's not irrational. All right, take the square root of 5 on your calculator. Is that irrational? Oh, by the way, I'm not giving you the C choice. Number 6. It repeats. It's a decimal that repeats. Is it rational? And last question. Is this one irrational? Does that repeat? It's got the dots, but no line. Look at those numbers. Don't be fooled. Well, you survived another math lesson. Next lesson, we're going to start talking about fractions and all the fun we can have with them. Thanks for watching.